Welcome back, everyone. We are going to talk about triangulation now, and this is basically where I finally give you a purpose for all of that stuff we did with triangles back in like September and October. Because basically what we're going to do is we are going to be able to measure distances that are too long to actually measure by using things that we can physically measure. Here's what I mean. Let's say I wanted to know how far away that tree was. First thing I'm going to do is draw a line that is as close to perpendicular meaning that if I were to draw this, as close to a 90-degree angle right there as I can possibly get. Next thing I'm going to do is I'm going to get out a protractor. And so I'm going to take my protractor and put 90 degrees right there. And then I'm going to measure. Okay, if I look with my protractor still pointed, so 90 is right here. If I measure this angle, where does that cross my protractor? And so let's say I measure that to be 62 degrees. Now you're going to take your protractor and put 90 degrees right there. And you're going to measure this angle. And let's say that one works out to be 82. Last thing that we need to do is we need to get a measurement that we can actually measure. We can measure this baseline, no problem. So let's say we measure that, and it works out to be 50 meters. Now what we're going to do is we are going to get out our pen and paper, and we are going to work through how to actually solve this. So I'm going to start by drawing a scale diagram. Super important that you do this to scale because we're going to be using the scale to actually measure. So I've drawn this line. If I said, that's probably not a good scale. Let's say 1 centimeter equals, we'll go with 5 meters. So if 1 centimeter equals 5 meters, and I had, what did I say, 50 meters? That means that on my scale diagram, I should be doing 10 centimeters. So let me mark that off as 10 centimeters. Then I'm going to use my protractor. So put 90 degrees right here, find 82, draw a dot, move my protractor away. And I'm going to then trace that line up as far as I can go before I run out of page. Then I'd move my protractor over here, and if I said 64 was the other one, move your protractor away. And we're going to go like that. And then that tells you that this right here is where your tree was. Okay, so how do we actually use that though? So we figured this should be 62 degrees. We measured it. We measured this. We measured this. What we can do is we can draw this line right here. And then if you hold a ruler up to that, let's say that on your ruler, you measure this to be, let's go with 25 centimeters. Because this is a scale diagram, you can use the same scale as this right here. So you can say, okay, if 1 centimeter equals 5 meters, 25 centimeters should be 25 times as much. So that would be 125 meters. And then you could say that this tree in the previous question, or the last page, was 125 meters away from the person right there. So this is a lot of using scale diagrams. I've got the math all put right there for you. If you do need a hand with this, come talk to me during office hours, send me an email. We can work through this part. But I wanted to focus on the triangulation. Next thing to talk about is parallax angle. And so if you think back to like 2004, when the Flames pretty much won the Stanley Cup, but didn't actually. It was because of parallax angle. And so what happened is to score a goal, the puck has to go over the line all the way, like completely. And it was really close. So what they did is they took their video camera, but their video camera was at an angle. And so they had it on an angle, and from that angle, it looked like the puck was all the way over the line. But if you were to look at it from straight down, they didn't know for sure if the puck actually was over the line or not. So because they weren't 100% sure, they're like, you know what, if we let this goal stand, then you win the whole Stanley Cup. We're going to say it doesn't count, keep playing, and then see who wins. And of course, it didn't go our way. Here's kind of a demonstration of how that works. Let's say I put my thumb over that, and you are standing right there. You are not going to be able to see the smiley face anymore. But if you move over to the right like that, so you're now at a different angle, well then you're going to see that picture over there because you can kind of see a little bit of it on the other side of my thumb. If you move over, if you move over like that. That's essentially what parallax angle is. So after we figured out that we rotate around the sun, heliocentric, we realized that we could use that because this is a significant distance here and a significant distance here. So if we figure that out, well then we can triangulate to figure out this distance. And then if we see that in January, we have that angle, but in July we have that angle, now we can use our scale diagrams and kind of reverse triangulate to figure out that baseline there and know how far apart those two stars are.